Great. Okay, so this is going to replace the tragically lost liver slide, or liver presentation. I'm hopeful that my bird is quiet during this presentation, but if you hear bird noises, it's because my bird is near me and wants to eat seeds. Okay, so let's begin. We are looking at a chunk of pig liver, and it's been stained using a technique called Mallory-Azan, and that is a contrast technique. And as you can see from the images here, there's blue outlines and it kind of looks like it's tiled almost. And that is because the connective tissue that separates the liver lobules is stained blue in this stain. It's nice because it makes them easy to see. Here's why that's good for you. Your task is to locate something called a portal triad or liver triad. And triad refers to a grouping of 3 tubes that tend to be near each other in this tissue. So let me go ahead and get my highlighter, and I'm going to highlight one lobule of the liver for you. Maybe not in yellow. How about orange? So I'm going to highlight a lobule. This is the one I like the best. A lobule is just one of these approximately hexagonal regions. So there's one, and I overstepped the lines a little bit, but you get the idea. So for example, here's another one. And in fact, all of the pieces of hepatic tissue separated into this shape by connective tissue is a lobule. So that is the definition of a lobule. It is one functional unit of the liver, let's say. So let's zoom in because you find the portal triads at the edge of the lobules. So even if you look at this relatively low magnification, you can kind of see some groupings of tubes. Whoa, my dot is too large. Here we go, let's try that again. So here's a grouping of tubes, and I can see one here, one here, one here. So those are gonna be what you're kind of looking for when you're looking for portal triads. So let's go have a closer look at those. Hello, I would like to zoom in, please. Okay, I guess we're doing it this way. So here's that lobule that I highlighted first. I'm liking this one the best. Oh no. So I said approximately hexagonal. If you go ahead and crack your textbook and look at the illustration of the liver histology, you'll see that the artist has rendered it an exact hexagon, which looks nice. But that it kind of tends to cause students to incorrectly believe that they're going to look hexagonal in a histology slide, and that's just not the case, as you can see. So keep that hexagon in mind, but loosely. And then I'm seeing, okay, I was just checking the chat real quick. I appreciate you guys' collaborative efforts to keep each other abreast of current events. Thank you. Alrighty, so you'll notice this hole in the middle. I'm gonna switch colors here because I'm thinking that you guys probably are not having an easy time seeing the orange. So this hole, that's a little bit better, is the central vein. Okay, here's an old trick that we found in previous iterations of EpicPen, is that if you just make yourself a little white space, you can write more clearly. So that's a central vein. Also, I'm going to build up this drawing, so I'm going to leave that label in place, and then we're going to label some of these other tubes down here. And And only after that am I going to zoom in on the tubes in the triad. So there's going to be a brief moment where all of this stuff is kind of labeled, and that might be a good moment for you to take a screen grab if you are able. I will do a short pause at that point. So if you're watching this live, not the recorded version, now would be a good time to just pull up your screen capture application so that you can do that. Okay, so at the center of each lobule is a central vein. At the edge of the lobules are branches of the hepatic portal vein, not the same thing. So central vein and hepatic portal vein, different veins. So let's see, in this triad, I'm looking, I'm seeing portal vein branch. Here's another one. Here's one. And here's one. So I'm actually going to label these in black. So I'm just going to call them hepatic portal vein because they're really a branch of it, and I don't feel like writing branch. So all of these things are that. So if you remember from both vasculature and from the digestive system, and one of your case studies kind of looked at both, you'll recall that the hepatic portal vein delivers blood from all of your abdominal viscera, and it passes that blood through the liver before sending that blood back through the heart and into regular circulation. And that's because that blood is coming from your guts, and your guts are where you absorb stuff that you've eaten. Hopefully all of that stuff is fine, but there's a chance that some of that blood might contain things from your diet that are not healthy for you. So one of the liver's jobs is to filter that stuff out. So blood is going to enter each lobule at the portal vein, and I'm going to pick a different color for my imaginary blood here. Hello. So I'm using dark blue for venous blood. So blood is going to trickle from the portal vein branch to the central vein. And as it does that, it's going to pass by all of the hepatocytes, which you'll see in more detail when I zoom in. And those hepatocytes have the opportunity to clean the blood that they have come in contact with. So it's a filtration system. It's not that different from, for example, a filter in your fish tank. Works the same way. Water goes in, it trickles through some carbon and stone material. That material cleans the water, and then the water that comes out is clean. Same idea here. It does this through liver sinusoids. So goes through sinusoids. And I'll show you the sinusoids as well. Okay, so I have a couple more things I need to label, and then we'll zoom in. One of those things is, let me go back to my blue. So I've got, this is bile duct. And it looks like artery. I'm going to need to zoom in further to confirm that that's an artery, though. You'll also notice that not every corner of the lobule has the same tube. So in theory, they do, but when you slice a liver, livers are squishy, and it also depends on the angle, right? So some of these lobules look incomplete, not because they are, but because the angle was not quite right to get the entire lobule, the angle of the slice. And then there's a question, which is the blood that passes from the hepatic vein to the central vein oxygen poor blood? Great question. The answer is sort of. And I'll address that when we zoom in a little bit more because it's an important point to hit. So thanks for asking that. So I'm going to pause here just for a moment so that if you want to screen grab this, you can. And then I'm going to zoom in probably on this area right here. All right, that's long enough of a pause, I think. So let's zoom in, shall we? Okay, good. My suspicion is confirmed. Oh, hold on. Okay, so what I've done is zoomed in on a corner. And so the blue stuff is connective tissue. I know that you're used to seeing collagen fibers be pink, but in this particular stain, they're blue. It's just a feature of the Mallory Azan stain. So all that blue stuff, it's just collagen. It's just supportive connective tissue that is supporting these tubes. So let me do some labeling. So this tube is bile duct. I'm realizing that that green's really hard to see in text, so I'll switch to black. And you might be wondering, okay, how do you know? Great question. I am looking very closely at the epithelium that's lining this. And if you really, really look, you'll see that it's cuboidal. I know that it's not the most straightforward, simple cuboidal epithelium you've ever seen. But you guys are, you know, almost to the end of 242 and you're epithelial tissue experts by now. So if you look closely, you're going to see two things. One, the cells are cuboidal. And the other is, if you look really closely, you're actually going to see that they're ciliated. So ciliated cuboidal epithelium is not super common. You really only find it in places where a substance needs to be moved through a duct and it needs a little bit of help. So that's the reason for this. Bile can be sludgy sometimes, so it needs a little bit of extra oomph to go. Okay. So both this and this long skinny guy are portal vein branches. And then let's switch colors once more. This and this. These are branches of the hepatic artery. Okay, so there was a question in the chat from someone whose name I won't say because I want to respect your privacy since I'm posting this on the internet. But it was an awesome question and I want to acknowledge it. So the question was, once more, is the blood that is flowing from the portal vein branches to the central vein, which is off screen above and to the right, is that blood oxygen poor? And I said kind of. Here's why.
That is weird from a circulatory perspective. So you guys are used to thinking about circulation as being, it goes from arteries to arterial,
Capillary beds, to venules, to veins, and back to the heart. Full stop, right? There are places where that's not true, and this is one of them. So here's what happens. And also I'm gonna pause here for a moment. So if you'd like to screenshot this, you can, and then I'm gonna erase it and draw something else. So just take a moment to screenshot this if you need to, and then we'll move on. Alrighty, so hopefully you had a chance to do that, because goodbye. Okay, so I'm gonna zoom out a teensy bit. Hopefully enough that I can see that's not our that's our central vein. All right, so the central vein is in the upper right-hand corner, and the portal triad's in the bottom left. So what we get is this weird situation where we've got blood from the portal vein branch trickling through the sinusoids, which are tiny little spaces between the hepatocytes. I'll zoom pretty close in and show you some sinusoids in a moment. But we also have blood from the artery that's exiting and entering the sinusoids as well. And that's because, of course, the hepatocytes need oxygen and nutrients too to do their jobs. So what ends up happening is that the blood mixes. So the blood that trickles in and through the sinusoids is really a mixture of oxygen-rich and oxygen-poor blood. And that's not something that is very common in circulation or in the body at all. It's pretty unusual, fairly specific to the liver. So that's something that's cool about the liver. Other cool thing, there are little channels for bile that you can't see that well on this particular slide. You need a special stain for it. So the general direction of blood in the liver is from the edge of a lobule towards the center. The general direction of bile in a lobule is from the center towards the edge, because of course it has to drain into that bile duct and then be carried away. So we've got mixed blood moving in the opposite direction from bile. So that's the reason why the liver histology looks the way it does. Is it's an organized filter that also happens to produce a useful substance. So it's doing double duty, and it's shaped in a way that's very specific to the jobs that it does. Okay, so now I'm going to zoom in and show you a couple sinusoids, and I'm also going to switch slides to a different one, because while I love this particular slide for portal triad stuff, I do not love its sinusoids that much. Okay, so really the sinusoids are just kind of spaces between hepatocytes. So if you remember sinusoids from the circulatory system lecture stuff, you'll recall that they're pretty disorganized. They're basically a really cruddy capillary with a lot of open spaces. Sometimes that's useful. Here's one of those places. So I'm outlining one here. You can actually see some red blood cells in there. And then you can see it kind of tapers off back this way out of the field of view. So there's one. Here's another one. Here's one right here. And so on and so forth. I can tell that these are sinusoids because I've looked at slides like this many times, but it's not a beginner histology skill by any stretch. So I'm going to try and show you some ones on a different slide that are a little bit more obvious, because as you can see, these ones are quite subtle. The blood in the central vein is coming from the portal triad. So the blood is going from the portal vein branch through the sinusoids, and it's ending up in the central vein. And then the central vein, all of those converge on a series of larger and larger veins until that blood exits the liver via the two hepatic veins. So hepatic veins, no portal, because they're not part of the portal system anymore. All right, so let me go find some better sinusoids to show you, and then we can move on to other stuff. I'm trying to recall which of these two I liked for sinusoids. Let's try this one. This one has fairly decent lobules, but they're not as spectacular as the previous. But it has really nice sinusoids. So sometimes with slides, you have, really awesome one thing and really cruddy another thing, and that's what we're seeing here. So these sinusoids are pretty nice. So you can see, here's one. It's probably connected to this one. You can actually see the point at which it drains into the central vein. Here's another one, for example. So blood is coming through these, having been cleaned, and then it's entering the central vein, and the central veins will converge on each other until they eventually become the hepatic veins, and that blood exits the liver. So that is liver stuff. Why anybody would report that video is beyond me, but internet people are weird. Let's see if there's anything else here. That's a nice bile duct. Let me show you that epithelium. So the epithelium is a little bit clearer in this image. You can see that it's very cuboidal. See that? And then you can also see the faint cilia that are going to help move the bile along. Okay, so let's go over to a very, very quick review of pancreas, and then we'll do a little bit of salivary gland stuff, and then I'll be done with the presentation. Okay. I think it is under endocrine as well as, yeah, here we go. You may recall from the first practical, there was that issue where students were putting islets Gomorrhae for some reason. And I was puzzling about why. Gomorrhae is indeed, as I said previously, a stain. So it has nothing to do with the name of the tissue structure, but rather it's the dye that was used to stain it. So a reason to be careful about Quizlet decks. All right, so here's a chunk of pancreas. The reason that the Gomorrhae stain is useful is because it tends to resolve pancreatic islets a little bit better. As you can see here, they're very obvious, right? So we've got really obvious islet there, 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 and there. So those are the endocrine structures, obviously. Let's go check out some of the exocrine stuff as well. So basically anything that's not an islet is going to be exocrine tissue. And groups of exocrine cells have a special name. We call them acini. That's A-C-I-N-I. So let me just outline a few of those. So there is one exocrine acinus. Here's another. Here's another. Here's a big one. So these are going to be secreting the digestive secretions that leave through the hepatopancreatic sphincter and enter the duodenum to begin the chemical processes of digestion, right? So we've got trypsinogen, chymotrypsinogen, and then as you guys know, those are all converted once trypsin has been converted or trypsin has been converted from trypsinogen by enteropeptidase. So it's that weird sort of cascade event. So that is where all those enzymes come from, the little green circled guys. So what else have we got here? Similar to the liver, we've got groups of tubes. And the reason for that is just because tubes, be they an artery, a vein, or a duct, they need supporting materials so they don't collapse. So they're wrapped with connective tissue, and it's easier to just have them run in groups. So there's no other reason than it's just an engineering problem being solved by just put them together. So here we have some connective tissue, and we've got a branch of the pancreatic duct. So these ductal cells are going to respond to secretin, for example, by secreting bicarbonate-rich fluid. The exocrine secretions of the acini also dump into the pancreatic ducts. So we've got this kind of watery alkaline mixture that includes enzymes. This is an artery. I can tell because I'm seeing a internal elastic lamina there, and I can also see the outlines of some erythrocytes, even though this isn't the right stain for them. And then over here on the left is the weirdest vein I've ever seen. Something about the Gomori stain is making the layers of the vein look very funny. So it's not probably one I would pick for a test because it looks kind of misleading, but it's in front of us, so I might as well tell you it is a vein. It almost looks like there's little guys on stems growing from the wall of this thing for some reason, which is very peculiar. So just goes to show you, not all stains do all things well. Okay, so that is pancreatic basics. Just a friendly reminder, in addition to the stuff on the slide that is on your list, there's going to be other random stuff. For example, I'm seeing a clump of adipocytes right here. And then up here, I'm seeing some septa, which are just dividing connective tissues. So be aware that there are many other structures in each organ than you are responsible for knowing. And this is just me saying, like, hey, it's a good idea to make sure that you have your, thinking cap on, so to speak, so that you can use logic to figure out what's what. So be asking yourself, well, I think that's a vein, but what's the layers look like? Or is this a duct, or is it really just some adipose tissue? So keep your connective tissues and your epithelial tissues at the top of your mind when you're looking at all this stuff, and be using those skills to figure out what things are which things. Okay, so I promised you some salivary gland stuff, and away we go. Salivary glands, by the way, are pretty similar to the pancreas, minus the endocrine function, because they're just exocrine acini and ducts. So let's have a look. So I am going to pick the submandibular gland. Also, I'm going to sneeze. Hold on a moment. Okay, crisis averted. I just didn't want to sneeze directly into the microphone. That would be rude. All right, so I'm going to pick the submandibular gland. Another thing I want to remind you of, since you have a practical coming up, is a mistake that I see students making, and I think I understand why, but I'd like to help you avoid it because I'd like you to have the success that you want to on practical. So yes, over here in the sidebar on Histology Guide, there are terms like stroma. And these are legitimate terms. They mean something. They are not on your list of stuff. And they're general. So like, you know what else has a stroma? The ovary. Basically, anything glandular that is supported by connective tissue has a stroma. So while it's a valid term, it's never going to be the answer to anything on your test. So I think what happens is if I circle something and a student's maybe running out of time, maybe flailing a little bit and doesn't know what the answer is, they click on over to Histology Guide and they just kind of pick one of these words and type it in sort of out of desperation. So a better idea would be to take your list and cross things off and be like, well, it doesn't look like a duct, so that's out. And it's not a mucus acinus, so that's out. So use your list for process of elimination tasks like that, not this sidebar, because some of these terms are just not going to be things that are useful to you. Okay, so seeing a lot of light spots, a lot of dark spots, some red, some tubes. So let's dig in and see what we've got. So right in the middle here, we've got a very large duct. Salivary gland ducts are one of the only places where you're ever going to see stratified cuboidal epithelium. It's not a common kind of epithelium, but you can see it here. So you guys can see that. So this is a duct. Happens to be a real big one. This is a vein. Here's another vein. And as you can see, they're packaged in connective tissue. If I look closely, I can also see some nerves here. And that makes sense because your salivary glands have to be controlled by something. And indeed, they're controlled by nerves. Okay, so let's zoom out a little bit and see what else there is. This space right here is an artifact. So if you look, you can see the collagen fibers are kind of torn up. That's just a place where, as the knife passed through the tissue, it did a little bit of damage. So that's not anything. So now I'm going to navigate over here. And I'm going to zoom in on some of these areas where there's a mixture of things, because what I want to do is help you be able to figure out which things are what, even if we're a little bit zoomed in. So let's zoom in. All right, so we've got sort of three classes of cells and of colored things here. So we've got these light pink guys with very obvious nuclei. We've got these darker guys that are arranged in clumps. And if you look closely, you'll see that the clumps of cells, the nuclei kind of tend to stay away from the edge of the clump, so they're middle of the clump, so they're all at the edge. And then finally, I have these sort of lighter colored ones here. So those are the three things you're dealing with when you look very, very closely at the salivary gland. So these ones are easy. They're ducts. How do I know? Well, I have a cuboidal to columnar maybe epithelium, and I've got a lumen. So here's another one. Now, granted, you can't actually see the lumen in every single one of these. It just depends on the angle of the slice. For example, this one, no obvious lumen, and yet I know that it's a duct because its cell color and cell morphology matches its neighbors. So duct, 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 duct. So many ducts, all gathering saliva from neighboring acini. So now we get to acini. Serous acini stain purplish and they appear granular. And in fact, if I go ahead and zoom, way in on some of these serous acini, if you look closely, you can actually see little tiny dots. So those, here's a really good demilune. Let me outline it for you. Demilune just means half moon. So when serous cells are smushed up against a mucus acinus, they take a crescent moon shape. That's why they're called serous demilunes. There is no difference in function between a serous demilune and a regular old serous acinus. They have the same function, they are just two different shapes. That's all there is to it. But those little tiny specks are secretory granules that are a mixture of water and salivary enzymes. So enzymes like salivary amylase, which helps us digest starch, and lingual lipase, which is a lipase that digests fats. So that's what the granules are. You're literally seeing clumps of enzymes with your eyes, which is cool. Okay, so those are your serous acini, both regular style and demilune style. And now let's move on to mucus. So mucin is a protein, and it's a protein that attracts water and has some sort of gel-like functions. That's why, you know, mucus or phlegm is kind of sticky and stretchy and gross to many people. It also just so happens that mucus does not like to pick up stain very much, especially not hematoxylin and eosin, which this is. So that's what these light cell clumps are. So these are all mucus acini. And sometimes you even get a solitary mucus cell like this little guy. Not super often. So here's another one. Usually they're in clumps. So the reason I picked submandibular gland, and to be perfectly straightforward with you, the reason I'm going to mostly pick submandibular gland for quiz questions is that of the three salivary glands, you've got your parotid, your submandibular, and your sublingual. The submandibular is about half and half mucus and serous. The other two, not so. So this particular slide just gives you a good chance of seeing a nice mixture of different kinds of acini, including the chance to see serous demilunes. Okay, so that concludes the video recording I wanted to do for you today. So I'm going to stop recording now,